Hello everyone, it's September 28th. Let's get on to it. Minimum score triangulation of polygon. You have a convex inside of the polygon where each vertex has an integer value. You're given an integer array values where value z is the value of the ith vertex in clockwise order. Polygon triangulation is a process where you divide a polygon into a set of triangles, and the vertices of each triangle must also be vertices of the original polygon. Note that no other shapes other than triangles are allowed in the division. This process will result in n-2 triangles. I think what this means is if you're given a polygon, a convex, and then triangulation is you take the vertex and you can form a triangle, and then you form a triangle and you form a triangle. So this is a 1, 2, 3, 4, 5, 6. So n is equal to 6, so we can get 4 triangles, which is correct. And I think it also means it cannot cross, right? Which means if we don't do it this way, right? Say we do it this way, and then that's the only other way. Yeah, 1, 2, 3, 4, you have 4. You divide a polygon, yeah, you have it divided into a set of triangles, and this process where you will triangulate the polygon. For each triangle, the weight of that triangle is the product of the values at its vertices. The total score of the triangulation is the sum of these weights over n-2 triangles. Return the minimum possible score that you can achieve with some triangulation of the polygon. So we need to divide them in a certain way that, so it's just a division, how we divide them, right? So this is only 1, you can only have 1. So this, actually, it's interesting, it's 4, right? So we have 3, let's say 7, oh no, clockwise, 4 and 5, right? So it's 4, so we have to either this or this. So you do this, so it's 3, 4, 7 multiply, and then the 3, 4, 5 multiply, and then the answer is 375 times this, and then 347 times 144. Okay, so n is 50. Made me feel like this is a brute force again, because n equal to 50. Let's suppose it is brute force. How would you brute force this? So you have a list. I mean, there are different ways to get this triangulation. So at the end of the day, right, all of them has to be, yeah, they're not necessarily, like these three not necessarily need to form a triangle, right? I can say these three form a triangle, right? And the problem is converted to, so I basically take this one out. So you have 1, 2, 3, 4, 5. So basically have this tell me what is the minimum, because then you need to add to this. Okay, so basically you take this and you have this, then you will find the minimum of doing this one, right? So we're converting this problem. All right, well, we're simplifying this problem. Now, because this is the way to take it, right? And you will have, like, no matter how you divide them, here's my theory, no matter how you divide them, you have to go, one of them has to be like this. So you either take it like this or you don't take it like this, right? So I'll say I'll take it like this, and then I'll compute whatever it is. And if you don't take, like, say you will break this one up, right? You say this one I will break up. So if you break this one up, then yeah, you just break it up. then somebody else will have to take. So yeah, essentially you just grab 3, find the remaining. Grab 3, find the remaining. So in this case, we have 6. It's like this, right? We have 6. So we have 1, 3, 1, 4, 1, 5. So I say I'll take 1, or I'll take this by itself, and then I have, you know, this, right? We have 3, 5, 1, 4, 1. So the question is, how do I, this feel like DP, right? You say I don't want to redo this. So I say if I take, you know, I take this, right? Then we have this. And is it possible through another process you will get this one as well? I think the answer is, because to get this you have to take out 1, right? That's the only way to get this. You cannot get this through other way. So to get this, you have to take out this one, and you have to take out this one. Right? You have to take out those to get this, and there's no other way to get it. So that's the only sequence. So it's essentially the sequence of taking out the vertices, right? So in this case, we can take out 3, or can take out 1. So it's just like a permutation, right? It's like you have different permutation. You take out this one first, you take out that one. So what's permutation of 50? That's ridiculous, right? That's not gonna work. But we don't need to go that far. Yeah, so like in this case, okay, I'll take out 3, right? I'll take out 3. So it will be like this. Yeah, so I take out this first, or I take out this first, or I take out this first, I take out this first, I'll take out this first, or I'll take out this first. And every time when you take it out, you get some remaining, right? And when you take out some, so yeah, there will be repeat. Like if I take out 1 first, right? If I take out 1 first, then we have this 3, 1, 5, 1, 4. I take out 1 first, and then if I take out this one, then we end up with the same thing as this, right? End up same thing with, as this. So that's when we need to find a way to get a, but how? I mean, in Python I could use a tuple. Yeah, I think the difficult part is how do I represent the state? 50. 50, you say. Long is what? It's 64, right? Long is 64-bit. I can use bit. Long C++. Long number of bytes. Number of bits is 64. Yeah, it's 64 byte. It's 64 bits. So I can use a number to represent which one got taken. Now we're talking. Now we're talking. And then, yep. Then we just, go through all the positions, right? Go through all the positions, and then we simply, we find a position if it's set, and then we say, well, get this one, right? And then we do whatever, and then move on to the next one. We take this one, and then if we have done, okay, but it's very large. We'll use a set. We use a map. We use a map because we will not go down to the bottom. So whenever it's 3, that's it, right? Whenever it's 3 set bit, and that's it. So we don't have to get to all possible combinations. Let's give it a shot. All right, let's give it a shot. And we start with n. So let's give it a shot. Oh, I do need another code. This is 39. Since the length of values is at most 50, we can use a Bitmask to represent the state of the current current polygon, right? Of the current polygon after some triangle has been removed. Okay, so now the question is, can we do a bottom up? I don't want to do top down because top down has some more setup. So bottom up would be, I need all different combinations of 3. Right? All different combinations of 3. Oh, that I'm not sure about that. Because you have 50. Right? And then any 3 can form. So like 1, if I start with 1, I can, all combination we can do 50. So it's just, we have 1, have this and everybody, and then this and this everybody, this and this everybody, and then we move on. So yeah, we can enumerate all different combination for 3s, and that's our base, right? And then for each one of them, right? For each one, we put them into a it's like a queue, right? It's like the queue, the bottom thing. And then for each one of them, we'll just, we add. So instead of remove, we add, right? So like if I have this is my starting 3, now we say the next step, I'll add this one. But when you add this one, how do you know which triangle it is? Good question. How do you know which triangle it is? Well, when you add, it's because they are on the, so in this case, right, we have basically, because this is our starting point, so we have 1, 3, nothing, 5, right? Then I say I'll add this one, or add this one, or add this one, right? So I say if I add this one, what is the other 2? It's to the left and to the right, which is this, which is 3, and to the right is 5. Yep, exactly. To the left, to the right, to its left and to its right. And then here, yeah, again, to the left, to the right, to the right, to the right. And if my starting point is this, which in this case, right, it's gonna be 1 3 1 3 1, right? And then I say, okay, I want to take this one. So to the left is 1, to the right you have to wrap around, right? You just keep going, and if it's nothing, you wrap around. So you have that, so you get that, right? So that's when you add, and then you have a new state. But okay, so complicated ones. Let's say we have 4. Not really have a 4. We can start with like more complicated, right? So yeah, we have 1 2 3 4 5 6. Let's say we have this. Maybe let's redo this. Yeah, I want to get to the bottom of this. So I have 1 2 3 4 5 6. Let's say we have this, this, and this, which corresponding to 1, this 1, and this 1. Yeah, we have 1 1 1. So I have 1 1 1, and I say if I want to get this one, which is 3, I look to the left, I look to the right. That's good. If I wanted this, I look to the left, look to the right, and that's the new one we add. And then we have here, which is 5, look to the left. Okay, so I think it's the same. So yeah, we'll start with in that case, we still need to check if some has been already. So we still need a set, right? We need a set, we need a queue. We need a set, we need a queue. So I don't know about the runtime, but let's try this. So what we need, okay, I need a deck, right? Deck of int. So I need the queue, and I need an unordered set visited. All right, so these are the two I need. Unordered set. Okay. Yeah, I need unordered set. I need a deck, and then what I need is having the starting point. So starting point will go through. So let's go through all possible triplets, right? All possible triplets as the starting point. Where are you going to save the result? Put in the queue. Put in the queue. Why don't you use a map? If you use a map, it not only saves what you have done, but also you can have the value as well, so you don't have to put inside a queue. Okay, I think a map seemed to be a better solution. So we have to be an int and int. Oh, this is not an int. This is gonna be a long. Right, this is not visited. This is gonna be try vals. Okay, so for int I 0 I smaller than values, let's go get our value n equal to values.size. Okay, so ni plus plus. That's actually not true because I need 3, so it should be n minus 2, right? So it'll be n minus 3, it's minus 1. Yeah, so that's the start. I need a j, it's gonna be I plus 1, right? J smaller than n minus 1, j plus plus, and then the last one is int k is gonna be j plus 1, and then k is going to smaller than n and k plus plus. So that's our 3, and then long state, right, shall equal to 1 left shift I or 1 left shift j or 1 left shift k, because those 3 are filled. So that's my state. All right, that is my state. In fact, I think it's slightly, I guess it's fine. It's fine. It's fine. So that's our state, and I need a value, right? Need a value. So what I do is try vals state equal to the value is going to be values I multiplied by values j multiplied by values k. All right, so this is to set up everything, and I need to put this into the queue. So queue dot pushback state. All right, so boom, done. That is our starting point. And yeah, that's our starting point. And then we're gonna just it's like a BFS to go through all possible triangulations. All right, so while q.empty, right, while q is not empty, what the hell are you doing, man? While q is not empty, we're gonna go through. So we have int let's call it n equal to q.size, right? So we're gonna go through that number of things, and we'll say for int I equals to 0. We can just do another while. We can say while n is larger than 0. Okay, so I'll basically pop one out. So long pre equal to q dot top front. Okay, q dot pop front. All right, so that's a pre. And then what we're gonna do is go through this. I have n, so I know how many to go. So everyone we just check. If it's not, then we'll do it. And then I'll put, okay, so we should say for int I equals to 0 as smaller than n I plus plus, right? If pre and 1 left shift I is equal to 0, which means this one is not set, right? It's not set. So position I has not been set. Then we're gonna set it, right? So we say long current shall equal to pre or 1 left shift I, right? And if try vals dot contains current, if it does not contain, right? If it does not contain, that's when we are going to do the computation. So I know the position is I, right? So I want to know who is to the left and who is to the right. So what I do, how do I know who is to the left of I and who is to the right left of? So I need to find the vertex to the left and right of I, allowing wraparound. So this is the pre, right? We have a pre. So we have a pre. So we have to go through pre, right, to find the first one that's smaller than I. Now, we should do this. We should start from I, right? We go to the right and find the first one that we can get. And then we all start from I, we go to the left and wrap around, find the first one we can get. And that's the left, that's the right. So we're gonna say int right I, okay, shall equal to I plus 1. While pre and this 1 left shift this, while this has not been set, this is actually not right. We should do this is equal to 0, right? So this is while this is equal to 0, it's not being set, right? If it's not being set, then ri plus plus. Oh, actually no, ri equal to ri plus 1 will mod n. Right? We allow wraparound. So basically the first one that's equal, then we'll jump out, we'll get out, and that's that. And int left I shall equal to I minus 1. So while pre and 1 left shift left I is equal to 0, then we say left I shall equal to left I minus 1 plus n mod n. So this will give me the left and right. And then what we do? We'll do try vals state shall equal to values I, left I, multiplied by values I, multiplied by values right I. Okay, and then q dot pushback current. Current, it's not state. State does not work. It's the current. Right? Current. Yeah, it's the current. So if it does not contain, I'll do blah blah blah, I'll get it, and then Q put it in. And yeah, we go through all of them. We go through all of them, and then we try to find the one that has not been done before, and then we get all of them. Right, and then we move on to the next one. Right, we move on to the next one, next one, next one. So once this is done, all n of them, all this for loop is gone. So n minus minus. Then we go back to the front. We go to the next round, and the next round, and the next round. So eventually there will be no more. Right, because eventually Q, we have a Q size, right? In fact, here n equal to this, right? So if actually should I this Q no. That's actually not true. That's actually not true. No, that's actually not true. We should allow all different combinations because for the same, you have different ways to form them. So, right? You have different ways to form them. So that's actually not true. What we want is to keep track of the minimum of them, right? We keep track of the minimum of them. Like, because I want the minimum. So this is actually not right. Okay, so this is not right. This is not right. So I'm going to remove this. Okay, this is not right. So this is, if this is not, I get a current and I need to find the vertex. Okay, find the vertex. So this is STD. But do we push it back in again? We don't push back in again. We don't. So we have inside the queue, right? Inside the queue is the ones we visited. And then we can add one. So we get a new, then we will get its value and push in the queue. But once it's in the queue, we don't push it again. So they only exist in the queue for once, which means we still need some. So basically, we still need to check. We say if trivals, right, dot contains current. If trivals dot contains current, then then this shall be minimum try vals current and this, right? Else, if try val does not contain, so try vals current will equal to this and I'll push this in. Right, if it contains, that means we have already visited before, so we don't have to push it back in again. I just need to update its value. Right, I just need to update its value if we have not seen it before. But here is the issue. If the current is this, right? So we go through, so each round is all four, like all different combinations for 4 vertices, and then all different combinations for 5 vertices. So going through this will definitely get us to the minimum for the 4 vertices, for all combinations for 4 vertices, right? I'm pushing the 4 vertices, and next time the 4 vertices comes up, I'll just update it. I don't have to push it again. So I think this shall be right? And then eventually, towards the end, when we have, 5, so just missing 1, right? And then we pop it out, we get in, and then we, get a minimum for that. And then push it in, right? And then we'll have only one value at the end. One value, n equal to 1. So this one pop out. I got nothing, right? I got nothing because everybody. So you don't do anything. So you just pop it out, and that's the end. Which I don't want, because I want to say Q is not empty and Q dot size is larger than 1. Actually, this shall be good enough, right? So Q size is larger than 1. So once the Q size equal to 1, which means there's only 1, which is the final result, what I do is I think I can just return try vals Q dot front. Not sure. It's just pretty shoddy, I feel. Very shoddily put together. Let's see if it works. Shift got to the negative. Oh, I have this have to go plus n as well. That ain't right. Okay, some issues. Let's debug this thing. Values. What was this? 3745. 3745. This is min score triangle values. Looks good, and I will start from here. Twenty 29. Yeah, 29. Click here. All right, so what do we have? We have a Q. I have 4 values because I have, 3, 7. So I have like 0, 1, 2. This is 0, 1, 2, right? 0, 1, 2, 0, 1, 3. I think this is 0, 1, 3. Yeah. And then 1, 2, 0, 1, 2, 0, 1, 3. 0, 1, 2, 0, 1, 3. 0, 2, 3. Right? 0, 2, 3 is 13. Yeah. And then 1, 2, 3. 1, 2, 3 is 14. Yeah, so that's the start. And let's see, try vowels. I have this. So this be, yeah, 84. The answer is 3, 4, 5. 3, 4, 5, and 3, 4, 7. 3, 4, 3, 7, 4. Right, it's 3, 7, 4. So that's the 84. Right, so it's 3, 4, 5. Let's see, 3, 4, 5 is 60. 3, 7, 4 is 84. That's why the answer is 84. I think it's probably I think I missed something. Well, anyway, let's just go through this. So n is 4. Okay, so pre is 7. So this basically only have 1. Right, so this is no, 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 yes. Okay, so current will be 15. Yes. And to the right, to the right. Okay, that is also pretty wrong. Let me undo this. This has to be this mod. Not sure, maybe that's the reason why it's not working. How this is not giving me trouble, I don't know. Nope, I'm still not getting the right answer. That's okay, and let's larger than 1. Okay, I'm curious. Let's get to see what's queued out front, right? Because when it gets out, let's say queued out size. Yeah, I want to see a few things. So first of all, I want to see queued out size. Okay, and then queued out front. Just show me. Is it 1 and is it 1 and 15? All right, 1 and 15. I think this is wrong. Yep, this is wrong. It's wrong because I forgot to add the previous one. Right? So this is the current, the newly added. I need to add the previous, which is pre, which is try vowels pre. I don't know why I don't do this. And this has to be try vowels pre plus. Okay, I don't know if there's any easier way to express this. Yes, there is. So what I can do is here int current vowel equal to. So I'll do this, put in here, And then this just be current val. And this is current val. Right, current val, current val. Okay, now let's do this one. All right, looks solid. I just hope it passes. Oh, it's slow. Oh. Man, I thought it's because I'm like 50. Dude. TLE'd. I don't understand. You don't have to get all possibility out? I thought you have to get all possibility out. Alright, so this is brute force. Brute force, so this brute force TLE. Unfortunately. Yeah, I guess it makes sense. No, I don't think it makes any sense. Hold on, 2 to the 50. How much is that? 15 times 10 to the 15th. That is too much. Maybe it is not. Maybe it is not. Okay. Maybe it's a greedy? Can we do a greedy? For example, the biggest value, we should pair it with the smallest. Should pair it with the smallest 2. Okay, the biggest value, we pair it with the smallest 2. The smallest 2 can pair with everybody else. Huh. Maybe that is the solution. We find the smallest 2, right? No matter how. We find the smallest, this is the min. We find this is the min. Second min, this is min. And everybody just go with them. Because they are all larger than 1. So for these large values, if they pair with anybody else, it'll be bigger. So this is the optimal, which means in this case, we find the min is 2 and 2, right? 2 and 2, I see 2 2s. So the answer shall be 2 times 2 times the sum of the rest. Let me try. Let me try this. Okay, so I suddenly had this epiphany that for that the largest vertex, the largest vertex can achieve, right, for any vertex, right, that for any vertex, the only way to achieve the smallest triangle value is for it to multiply with the min and second min of the values. Thus, all we need to do is to find the min and second min, right? Second and min value, then and use these as a base of the triangle, and multiply the rest. Is to find the min and the second min value, and all the rest of the vertices must use these two to form triangles. Okay, so in this case, that will be ON, right? That will be ON. So we need to just find the smallest and second smallest. So I have to have a sum. So sum is 0, and int min shall be int max. Second min is also int max. So for int v of values, if v is smaller than min, actually no, this is actually going to go easier. Vowels 0, vowels 1. Okay, and sum is values 0 plus values 1. And here we're going to start with int I equal to 0 and 2, I smaller than values of size, I plus plus. Okay, so if values I is smaller than min, then second min equal to min equal to values I. Else if values I is smaller than second min, then second min equal to values I. It doesn't matter, right? If it's larger than, then we don't deal with it. And then sum plus equal to values I. Okay, so once we're done, we'll return min times second min times sum minus min minus second min. That's it. Let's see if it's correct. It's solution. Uh-oh, That is not right. That is not right. Huh. I missed something. I don't know. This times this. Oh, you cannot. Because you cannot. Oh. Okay. Yeah, this is not right. Yeah. It's not. It's not right. Because if you want to do it that way, then you are essentially not covering them up. There will be an overlap. Ugh. Then I have no idea. I have one solution that is wrong, and I have another solution that is TLE. I have only one hint. There is a triangle that uses adjacent vertices this and this. Depending on your choice, K of it, let's break down the triangle into two subproblems. 1 to K and then K plus 1. That is true. That is true. So it's like divide and conquer. There is a triangle that uses adjacent vertex. A0 and AN minus 1. Yeah. Depending on your choice K, let's break down the triangulation to two subproblems. A from 1 to K. I mean, I think I know what it's trying to say. It's trying to say, let's say this is 0, this is n minus 1. It's saying like there must be a triangle using these two. Is that true? There must be a triangle that uses these two as the base. Yeah, it must be. It must be. Because this must be in the triangle, and this must be in a triangle, so this must be inside the triangle. It's just we don't know which one it should be, right? So it can be here, it can be here. So what it says is, depending on choice of 1, because 1 can be a K. So K can be here, K can be here, K can be here, K can be here. So depending on your K, the problem becomes, because if you choose this K, so 1 to K, because you can, like, let's say K is here, right? So you do this triangle, right? So become from 1 to K, or K plus 1, because K is here. And this, I won't say K plus 1 though. I'll say it's actually 0 to K and then K to n minus 1, right? So it's this subproblem and then this subproblem. I don't understand why my other solution is bad. This feels kind of the same idea. But you still haven't solved the problem of how to Oh, then you depending on where the k is. But then you have the new thing. You don't memorize. We just, you know, set at the start and end, and I would divide. But that's not true, because if you do that and you say these two must form, then we can never do like this. Oh, we can, because if I set a k here, then we do have this. All right, let's copy the answer and then go back thinking about this another time. Oh, that's deceptionally simple. Damn, that's deceptionally simple. All right, I must not be thinking about it correct. But let's do this another time then. All right, that'll be it. Let's think about some other time.